Hey guys, this is Mitch with Finepoint CGI, and today we are going to continue our horror game by building a dynamic interaction system. So we're going to go through the process of planning out what we're going to build, then we're going to implement that plan. So we're going to build out a system that allows us to open up a door. We can pick up an object using physics. We can throw that object using physics. We're going to set it up so that when the object hits something, it creates a noise. And we're going to make it so that our enemy can react to that, allowing us to distract our enemy if we need to. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we need to do is we need to plan out what we're building. So with an interaction system, you want to make sure that it is as reusable as humanly possible. So we're going to need to introduce some new elements to our game. We're going to need to introduce a interactable interface, which I guess if we're going with a standard naming convention, we can go with I_interactable. That's actually standard from Microsoft, or I believe it's I_interactable. I don't know if there's an underscore or not, but regardless, we will be putting in a interface here for I_interactable, and we will define that interactable here. And what we'll have inside of this interface is we'll have a way to get our interface text. We'll need a way to play an animation. And we're going to need a way to actually interact with this. And since this is a I_interactable object, we may want the ability to pull back sound and sound information. And of course, that's optional, but I think that we would want that feature. Now, if I can remember how do I add stuff to this thing? There we go. So I'll click right here, and then we'll just add this guy. And those will be some of the interaction systems that we're going to need. Now, what I'm thinking for this is we're going to have two separate scripts, okay? And each one of them are going to get defined by our interactable. And right now, what we need is we need a door script, and we're going to need a Pickupable. And the nice thing about this is that we can later inherit things from these two objects. Now, I know that I could probably flip these guys over and make more sense, because usually you do stuff from left to right, but I like to make things difficult. But I can drag these guys over real quick, like so. There we go. That's a little bit better. And what we can do here is our door script should be pretty simple, okay? We're going to have the ability to interact. We're going to have the ability to play some kind of animation, right? And we need the ability to get sound, right? That's what these guys are used for. And basically, what we're going to do is if we come up here, we can just say play animation, right? And all we have to do for our play animation, which I'll make this bigger, like so, and throw this guy to the top, is drag this little diamond in here and just say door open. And we'll drag this guy in here, play closed animation. I'll just copy and paste that, play open animation, and then I'll invert my door open. And then we can go ahead and end. Which, if you guys don't know, you're actually technically supposed to end all of your functions. So when you do these designs, you actually are supposed to drag in this little black dot, this little red black dot, and that'll basically tell you that this is closed, that this is done. And technically, you're supposed to have a start as well. I don't know if Draw.io has a start, so I guess that's what this is. So you can just drag this guy in and put it like this and just say start. And that's technically how you're supposed to do it. Now we can select all of these guys and go into arrange and then hit group, and that will group them as one big thing. Now we also need our door to have some kind of interaction system, right? So since we have this guy, we have interact, so we can come in here and interact, and all it will do is just play this. And that's it. That's all it needs to do. And our door also has this play animation as a public variable because it's required. And our interaction will just have play animation, and that's fine. Get sound is not going to be used. So what I'll do is I'll just come in here, drag this guy here, and just have get sound. And I will highlight it red to say that it's not being used. Now, this isn't standard UML or anything like that, but this is just me planning out how I want to approach this. Now, with our Pickupable, on the other hand, we need to have a little bit more information, a little bit more stuff. So with our Pickupable, if we drag out a little box here, we're going to, of course, have our standard interact, get sound, and play animation. So we can just basically duplicate these guys. And I can ungroup this. I didn't think that it would pull my actual group, so let me just do that, and then I can trash the group. Now we'll have a play animation, we'll have an interaction, and we'll have a get sound. Now in our case, we are not going to use our play animation at all. We don't have any animations that this needs to have, so we can just highlight this guy red. So we'll just say style red like that, and we have an interact, right, like we expect. And all we're going to do is we're going to push out to a separate function, which is notify player of picking up. So we can just kind of grab this guy. We can send this guy up, and then we can just drag in one of these guys and just say player pick up object. And I will put a little pointer like that just to say it's going out to that function call. And then for get sound, all we're going to do is just return our sound. So I'll change this style to white. I'll just drag this guy in here, and we're going to return sound value. And actually, it should be current sound value, shouldn't it? So return current sound value. Outside of that, since our Pickupable needs to make noise, right? One of the big things that we have is our enemy can now be distracted by objects, right? We could pick up objects and we could throw it and then distract our enemy. And since we're going to be able to pick up objects, we need to be able to have a sound value for them to be able to read, so they know how loud that object is based off of where they are. They can determine if they heard it or not, right? So we need that functionality. Now, in our case, what we can do is we can have an event, which I'm going to use this guy as an event because I can't really think of anything else to use. And I'll just drag this in here, and this event will be on body entered. And I will arrange this to the top like that. And we'll say on bodied enter, we're going to play noise, get item noise, and then we're going to play that noise. And then we'll set our noise value. And we'll drag in an end just like that. And I'll probably need to drag in a start as well. That way we can have a nice event as well. Now, something that we have put in here is get item noise. That means that these Pickupables must have some way to house that noise, which means that we're going to need some kind of resource. And I know, like I said, this isn't exactly, UML, but at least it's getting us something. So we'll drag this guy in, and we'll just add an item resource. And let's define what an item resource is. Well, it's something that would house a noise level, right? It's something that would house a sound, right? So we'll say hit sound. And I think that's pretty much it. So I can just basically get rid of that. And we'll just kind of drag that into our pickupable. So that way our pickupable has, we know that our item resource exists. And I think that's pretty much it in terms of this portion of the interaction system. I think that will work. Now, we did call out our player here, and we don't really have a player designed system. So we'll need to kind of do that by ear. But what I'm thinking is pickup object will be pretty simple. So what I'll do is I'll create a tab down here, and we'll just say pickup. We'll just say player like that. And we will come in here and we'll just draw out a very basic function. We'll just say pickup object. And what I'm thinking what we'll do, and I think instead we'll call it grab object. I don't think it really matters, but we'll just call it grab object. And what we'll do is we'll basically just say, okay, if I don't have a grabbed object, so if I don't have a grabbed object, then attach object to player, else basically do nothing. I don't actually need anything there because I don't really need anything. If I already have an object picked up, then I don't really want to grab an object. I guess we could drop the object. Maybe that would be good. So we'll just copy and paste this and say release. And then we can just set our object. Set object to object or null. And we'll just kind of drag this like this, drag that like that. We'll drag in our start and our end. And then we'll just do this. There we go. And we'll do that. And there we go. And that'll be the beginnings of our player design because it definitely doesn't exist. And we probably should have some kind of, design to back up our actual player. Now, we are going to need to adjust our input as well. And I don't really want this to be a 6-hour planning session because it's already probably about 20-30 minutes. So I'm just going to copy this. And I'm going to paste it and I'll drag down here and I'll just say interaction system. And I will drag in a start and an end. And we'll just drag this guy down here. And what I'll do is I'll just come in here and just say if throw button pressed, then we're going to add an impulse to our object. So we'll grab object, which should release it, and then we'll apply an impulse to throw. And that should do it. So we'll just do that. We'll do this. And then this will probably get planned out a bit more in the future. Now, one other thing that we have to talk about is our enemy AI. So in our enemy AI, we have all of this stuff. And what we should do is instead, we should abstract this into a function that handles our sound stuff and allows us to actually, use our code, right? So what we'll do is we'll have a small loop and I'll pull this guy out and just completely get rid of that. If not, we'll just go to am I at point like so. And there we go. And what we'll do is we'll drag up here and have a function called get sound value. And we will move the text up to the top and I will paste. I should not have pasted. I don't think that was a good move on my part. Yeah, it didn't really do anything. So I'll just drag some stuff in. So we'll get our sound value, basically do a for each loop. So we'll get element off of sound objects. And then we will loop through it and check if sound loud enough. And then if it is, we'll come in here. If it is, then we'll set state to hunt. If it's not, then we're going to check if all elements have been iterated. And if not, then we will head back to our get elements off of sound. So if not, if so, like that. There we go. And then we can drag in our end state right here. And then we'll drag in our start state right here. There we go. And then all we have to do is we can grab this guy here and just say get next waypoint, get direction. Am I at my waypoint? I guess we could just drag it in right about here and just say get sound values. And I believe I had a section in here. I don't think I did, but I think that will be fine. And then we'll do the same thing when we are waiting or when we are hunting. So when we're waiting, we will get our sound values as well. So we'll just drag that in like so. There we go. And that got real messed up. So let me fix that. There we go. And I think when we're chasing, it's not going to be a problem, but when we are hunting, we are going to do that. And we'll need to change our hunting state to, actually, we do have a get sound value here, but it looks like it's looking around for player in the area is light level higher than configured value. So we actually don't need this or this. And we can basically just grab this. If I'm looking around for that and I can see my player, and I should be able to set state to chase if I can see the player. And what I'll do is I'll move towards sound and I will get my sound as well. And I think that'll work. So I think that'll work. Now I know that that was pretty long, but we do have our interaction system. So basically we're going to come in here. We're going to have an eye interactable that these guys are going to have. We're going to have a door and a pickupable. And those pickupable objects will make noise, and our enemy AI is going to figure out that that noise is coming from the object. It's going to go to that object. Also, our player is going to gain the ability to actually grab objects and throw them around and things like that. And that should about do it. So let's go ahead and build this. Okay, so the first thing we need to do is we need to actually set up our interaction system. So one of the big important things that we have is our door here. And this door has an animation for opening and closing right here. We built those out in the last tutorial. Now, let's first set up our eye interactable, our actual interface. So if we come in here to our scripts and I just double click on enemy.cs, that should open up Visual Studio here, and I'll probably need to resize it for you. So let me do that real quick. There we go. And what we'll do is we'll come into our scripts, we'll right click, add in a new item, and we will add in an interface right here, and we'll just call this interactable. And then inside of our interface is going to be our 4 elements that we talked about earlier. So the first one will be a string return, which is a get interface text. The next one will be void play animation. And we'll pass in a string of what animation we want to play. And then we'll have another one, which will be void interact. So we can interact with it. And then double, which will be our sound. And there we go. Now, your first question might be, what in the world is an interface? And also, we'll need to change this to public. I totally forgot about that. But what in the world is an interface, right? Because if you've never really worked with interfaces, you're probably like me when I first started software and I didn't know what interfaces were. Interfaces are basically a contract. It says anybody that uses this is guaranteed to have these functions. Okay, and the reason why this is useful is because if we have an object like a door, right, we can tell our player to say, this object is an interactable and I want to play its animation. And then that allows us to play its animation without me needing to say, is this a door? Is this a pickupable object or anything like that? I could just say, is this object interactable? Yes, then I know that it has this play animation and I can do play animation. And that's kind of the nice thing about interfaces, is that they allow you to say, I am guaranteeing that this class has these functions. And it can be super useful. Now, we also need to set up our door script. So let's right click, add in a new item, and let's add in a door script. So we'll type in door, and I added in an interface because I'm dumb. So let me delete that. Okay. And let me right click, add in a script, new item, and let me add in a door class. And I know I'm setting this up manually. Technically, if you did it outside of here and did it inside of Godot, it'd probably be a little bit easier, but I'm okay with doing it this way. So we'll say public partial class door, and we're going to make that inherit from a node 3D. And Visual Studio is going to automatically know that I am going to need to use Godot. So if you're using something else like VS Code, you might need to add that in manually. Now, part of the reason why I did it this way is because I don't really need my functions for ready or process. Or if I do need my ready, it should only be to grab my animation, so it should be pretty quick. So it's kind of nice to do it this way sometimes over top of doing it the other way. Now, if we want to use our interface, which is our interactable, what we can do is we can just hit comma, space, interactable. And you'll see that we have this really crazy underline here, right, in Visual Studio. If we right click and do quick actions and refactoring, we can just implement that interface, and it'll guarantee that our object has these functions in it. It's super nice and saves us a bunch of time. So keep that in mind. Now, first, we have our get interface text, and what I'll do is I'll make a public variable for that. So first I'm going to export this variable, and then I'm going to say public string hover over text. And that means that we are going to need to be able to hover over our object. So we'll have to build some kind of system for that. So we might need to go back to the planning board for that. But what we could do is we could just return our hover over text like that. Now we also have get sound, and our object does not need to play any sounds because it's not going to, I'm not going to make it so that if the door creaks that it makes the monster come towards you. Though if you wanted to, you could actually put that in here and that would work. For interact, what we're going to do is we need to do our if door open else or if door open, play our close animation, else play our open animation, right? So that means that we need a public variable up here. So, well, I guess we could do a private bool door open. And then we could just come into our interact and just say, if door open, then play that sound or play that animation. Now we don't have an animation player, so we could just say get node animation player, but instead let's just do that in a ready function. So we'll just say public override void underscore ready, and we'll just add in a global variable private animation player, and then we'll just set our player. So player is equal to get node of type animation player, and then we can just grab our animation player like this. Whoops. There we go. I'm fat fingering all the keys today. And then we can just say player dot play, and in our case we know that we have a close animation. And then we could just say else player dot play open, if I remember correctly, is our actual animations that we're playing. And then we'll just set door open equals to not door open. And that way it'll flip. It'll say if door's open, then close it. If door's closed, then open it. And it'll just flip the Boolean one way or the other. That way it works perfectly every time. Now, we may or may not want to export this out if we have a door that's already opened or something like that, and we kind of want to have it so the door exists and say, hey, this door was left open, right? And then if the player closes it, then it would flip that Boolean. And that's up to you, but in my case, I'll just leave it like this for right now. And that should basically do it. I don't think we need play animation, although maybe we will later. We might need to change our contract and just get rid of play animation. I don't think it's going to be necessary because we have interact. So there's no reason why you would use play animation now that I'm thinking about it. So I'm going to get rid of that, and I'll go into my contract and I'll just get rid of play animation. I don't think we need it. I think we'll be good without it. And there we go. Now we can set up our player able to run this basic script. So if we go over to our player here and we hit yes, because Visual Studio likes to, for whatever reason, mess up my line endings. And we'll need to have the ability that when we hit E, we can interact. Now, if we check real quick before we actually start our player stuff, let's take a look at our project here. And let's go to project settings, and let's take a look. So do we have interact? We do. I already set that up, so that's good. Now, if we look at our player, when we interact, we need to know what object we're interacting with. And one of the big questions that I had from a lot of people was, why am I not using the scene-based raycasting? And generally speaking, the reason why is because I don't generally like the screen space raycasting. However, this is one of the few times I will actually use it. And the reason why is because it's a little bit easier to use it this way than to basically call out spaces. Because of the way that cameras work, it's just a little bit easier for me just to attach it. So what we'll do is we'll right click, add in a child node, and add in a raycast 3D. And I'm going to set it to have a target position of 0 and a target position of -1.5. And that should about do it. And what I'm going to do is I'm going to set this so it has a collision mask of 4 instead. And I know what you're thinking. Why would we set it to collision 4? Well, I want all my interaction objects to be on layer 1 and 4. That way they interact with the world, but they also are collidable with this guy. And the reason why I'm not keeping everything on 1 is because if I had everything on 1, anytime I raycast this, I need to check if this is an interactable object. But if I have it on layer 4, I can guarantee you always that it's going to be an interactable object of some kind. And that makes things a lot simpler for us in terms of code. Now, we're still going to need to do a check if it's interactable just because of how Godot works, but it saves us some trouble. If we hit Control S and we come into our player, we'll scroll up here to the top right here, and we'll say private raycast 3D and call it head raycast like that. And then under our ready, we'll just say head raycast. And since it's private, actually, let me change this real quick. Head raycast is equal to get node, and we'll say get camera 3D because we have to pull back our camera 3D because of how this is structured. So we'll grab our camera 3D like that. Dot get node raycast 3D, and we will pass in our raycast 3D like that, and that will work for us. So now we have a good global reference to our raycast, or at least our good class-based reference to our raycast. And now if we scroll down to where our input system is, and as a tip, if you hit Control MO, it will fold all of your classes, and that can really help with this. So if I fold everything with Control MO, and then I come to get input right here, If we just come down to the bottom here before our return, we'll just kind of inject some of this code here. So first, we need to check if our head raycast dot is colliding. And the thing about this raycast is it will raycast every physics frame, always. So we don't actually need to tell it to raycast. It'll just do it automatically for us, which is really nice. So we'll just have it do that. And then we'll say obj object obj is equal to raycast head raycast dot get collider. And that'll just pull back the collider that it hit. And then we could check if obj is interactable, like that. And if it is, then we know interactable is equal to obj as interactable. And that way we can guarantee that this is an object that exists, that it's an actual interactable object, and that we can actually interact with it. And then we could just check if input dot is action just pressed interact, then we could just say interactable dot interact. And it's not that, so interactable dot interact. There we go. And that's it. That's all we have to do. We don't need to do any more work on our end. It just works. Hopefully. So we could just save this, and we can go into Godot and go to our level 1 wake up. And actually, let's go to our door first, and let's assign our door right here. Control S, and we will hit play. Now, if we run up here and we let our door open, and we come up to it and hit E, you'll see that nothing happens. So why is that? Well, if we go check out our door, we click on it. Let's take a look at our collision. We are on the wrong layer, so let's grab that and throw it on the right layer. Let's see if that fixes our problem. So if we run up to this door, hit E, there we go. Our door opens and closes. Awesome. Simple enough. So now we have a way to open and close our door, which is great. So now all we have to do is build up an interaction system that allows us to pick up objects. So all we have to do is create a physics object that we can kind of pick up and throw around and things like that. So if we go to scene, new scene, and we create an other node and we type rigid body 3D like that. And let's just call this grabbable object because it's just a test object anyway. So we'll just call it grabbable object, and I spelled grabbable wrong. There we go. And we will right click, add in a child node, and let's add in a mesh instance because we need to be able to see it. And we will add in a box mesh here. And let's make it nice and small, something about yay big. And then we're going to right click our grabbable object, add in a collision node, and add in a collision shape. And we will add in a shape, we'll add in a box shape, and then let's scale down our extents. So we'll just kind of bring our size down so it matches. Like so. I think we had our scale set to, if I look at my transform, 0.241. So we'll do the same thing here. So 0.241, 0.241, 0.241. There we go. And I'll hit Control S. We'll throw this in our scenes as a grabbable object. And we would be good for picking up this object, right? We wouldn't need anything else other than a script and things like that. But we also want to make it so it plays sound, right? One of our big things that we wanted was this can play sound when we throw it and hit it up against a wall. So let's right click and add in an audio stream player 3D. That way we have a way for this to actually play a sound. Now, if we right click our grabbable object and we attach a script, and we will call it pickupable.cs, and we will grab that, and we will make this also have the interactable interface right here. We'll right click it and we'll quick actions and refactor, and we'll just implement that interface, and that'll just implement everything. Now, with our interface text, because we don't actually have an interface yet, that will be coming in the future. What we'll do is we'll just put out a exported public variable. So export a public string, hover over text, and we can basically just say when you want to get your interface text, just return hover over text, and that should work. Now, for us to be able to pick this object up, we need to be able to tell the player to grab this object. So when we do our interact, we actually need to have it so the player can, pick this up and move it around and throw it and things like that. So we'll just make a scaffold function for that. So we'll just drag this guy out here like this, scroll down to the bottom, and let's just make a function specifically for this. So we'll just come in here and say public void grab object, and we'll pass in a rigid body because it's going to be an object that we can pick up, right? So we'll want a rigid body. And when we want to grab that object, we need to have some way to store that grabbed object. So let's scroll up to the top right here, and let's just say private rigid body 3D, that's 2D, 3D, grabbed object. And since it's private, I'm actually going to make that a lowercase g. And we'll scroll down to the bottom, and we'll just say if grabbed object is equal to null, then let's grab our object. So we'll say grabbed object is equal to body. Else, we want to set our grabbed object equal to null. And then we can just come into our interact, and when we grab our interact, we can just say player.grab object. And we'll pass in this. There we go. And that should pretty much be it, at least when it comes to our pickupable object for right now. Because we're going to need to play our effect sound when you throw it and hit something. But we'll get to that once we, need to. So let's grab our player and let's drag this over here and let's finish up this little bit of code. One of the things that I would like to do that a lot of games don't is I'd like my object to exist in physical space. A lot of times when people grab an object in a game, they basically disable collision, make it kinematic, and say, yep, you have this object in your hand, and you could just throw it through a wall. Like you could just walk up to a wall and let it go right straight through it. But I don't really want to do it that way. I think it would be good to follow kind of what Valve does, where the object maintains the rigid body status and allows you to whack that object up against the wall. And that also will double as a, hey, I bumped this object against a wall and now it's made a bunch of noise and the monster could hear that and come towards me. It adds that extra bit of fear, right? I have to be careful of this object. I don't want to just drop it, right? Because it could make noise, or I don't want to just push it up against the wall because it could make noise. So it helps with adding to that fear and adding to the gameplay elements. Now, how we're going to do that is we're going to use joints to actually hold on to this. So if we go back to our Godot project here and we come to our player, if we right click on our player and we add in a child node and we add in a joint, you'll see that there are a bunch of joints. So we have a cone twist joint, which is basically like, think of it kind of like a light bulb hanging from a ceiling. It allows you to twist this object in a cone. So it's really nice for that kind of interaction where I just need it to kind of twist in a cone shape. A generic 6 DOF joint is awesome because it allows you to basically pick an object up and keep it in that, keep it connected to another object, but also allow it to rotate and kind of get moved by other objects. Hinge joint allows you to hinge an object, kind of like a door. If you wanted to make your door physics, this is how you would do it, is you would make it a rigid body object and connect it to a hinge joint and a pivot point, and then you would allow you to grab and move this object. Pin joint pins an object to another object, which can be good and it can be bad. If you pin an object based off of its weight, it can fall down, but it'll still be connected to that object, kind of like a pendulum almost, right? So if you move the top of it, it'll slide the other one down and kind of swing it with it. but it doesn't necessarily force the object to suck up to it, right? To be connected to it, if that makes sense. And then slider joint just works basically like a sliding door. It allows you to slide an object along another object, basically. So what we're going to use is the generic 6DOF joint. So I will grab this guy. And then what we need for this to work is we need a point to connect this to. Okay, so if you look, they have A and B. We can assign node A and B to be connected together. So that means that we need an object for this to be assigned to. So what I'm going to do is I'm going to right click. I'm going to add in a child node, and I'm going to add in a static body 3D. And the reason why is because your object has to be a body of some kind to pin two objects together. So you can't just pin it to a node. It doesn't work that way. It has to be some kind of body object. And in my case, I'll choose static body. So I'll drag this out here so it kind of is in line with my lamp here. And I will come to my generic 6DOF. I'll come to node A and I will assign it to my static body and I will hit OK. And now I don't need to worry about collision because I don't really care if it collides with anything. So we'll just have to deal with the triangle. Or we could add a collision and disable it if you would like to get rid of that triangle. If we come up to our player and we click on our script and we open that up, we scroll down, what we can do is we can just set our body as connected to our generic 6DOF joint. So that means we're going to need a reference to our 6DOF joint. So if we come up here, we type private generic 6DOF joint 3D, and we'll call it our grabbed joint like that. I'll open up our ready. We'll come down here and I'll say grabbed joint is equal to get node generic 6DOF joint. And I believe we kept the default naming convention. So generic 6DOF joint. And there we go. And now we can come down here and we can basically just say grabbed joint dot node B is equal to body. And you'll see that, well, that didn't work, right? We have a underline here. And the reason why is because it requires a node path. So all we have to do is just type dot get path. And that'll pull back our path. And there we go. Now, something that we have to keep in mind is if we grab an object and we want to release it, we need to actually have something to assign to this path. And that's where an additional static object will come in handy. So what we'll do is we'll come back here, we'll come down here, and we'll duplicate this and just call this reset body. And then when we come in here and we want to release our object, we can just say grabbed joint node B is equal to grabbed joint dot get node static body 3D, and we can just pass in, I believe we called it reset body, so reset body. And that'll allow us to grab and release an object. And much like before, we also need to type dot get path. And there we go. And that should pretty much do it for us. So if we hit Control S and we go to our level 1 wake up and we drag in our grabbed object. So if we hit Control S and we go to our scenes and we grab our grabbable object, we can just drag this guy in like so. And then let's select him. I'll drag this guy up here. Let's make sure our collision is correct. It's not, so let's fix that. So we'll come in here. We'll come into our collision like this and make sure it's on layer 3 so our raycast can see it. And then if we hit play, we come up to this guy and we hit E. Well, it doesn't seem to be working. So let's see what's going on. So when we hit E, we're hitting interact, right? So we know that that code works because it worked with our door. So we know that it's going to fire off this interact. So it's going to grab this object with grabbable. So if we head over to our player and peek our definition, if grabbable object is null, which it should be, it should set our grabbed object to here, and then it should set our body to our path. So that should work. So the question is it colliding with the object first? So let's go to debug and let's set our visible collision shapes to true, and let's hit play and let's see if it collides with it. So it's not colliding with it. You can see how we have this big blue square in the center. That is our raycast. So it's obviously not colliding with it, which is not a good sign. My guess is in our level 1 wake up, it never set up our collision layer, which it did. So that's not a good sign at all. So let's see. So we have our collision shape. It's a box 3D. It's not disabled. It's the correct size, I believe. Yeah, it looks like it's the correct size. If we look at our mesh instance, that should be fine. Contact monitoring is off, but I don't think it needs that. It will need that in the future, but it doesn't really need it right now. So let's go to our player. Let's look at our raycast. Did I put it on I put it on the wrong layer. It's supposed to be on collision layer 4. I thought it was supposed to be on layer 3. So let's add it to 4. Let's hit Control S. Let's look at our level 1 wake up. Let's verify our object is on 4. That's fine. So it should be good. If we come up here, we hit E, you'll see the object now stays with us. It's a little weird because it kind of, swings wildly back and forth and it doesn't go up or down. If we hit E, it drops it and we can pick it up again. And it stays with us, which is good. So that means that we have our stuff actually working, which is awesome. But it's not allowing us to go up or down. And I just realized why. That's because this object is not going with our camera. It's actually here instead of up here. So if we drag this guy up here onto our camera, and then we go into our player and we update our reference, can't believe I made this mistake. We type get node camera 3D camera 3D dot get node like that, then it should work. I can't believe I made that mistake. I made that mistake earlier today too. So if I hit E, there we go. Now we can throw it around and it'll, stay with the player. Now you'll notice that it's really, really, really bouncing around, which is in some ways in your game might be a good idea because you can have it so the character can do something like this and like let go of the object by hitting E. But I don't really want to do it that way. So instead, what we'll do is we'll come into our DOF and we'll create some dampening factors, and that's going to help with reducing all of this. So we'll scroll up to our linear limit here, and we'll change our softness up to something like 1.25, 1.35, and that should help a lot with the amount of jiggle we're getting. So if we come in here and we grab this guy, you'll see it's definitely doing a lot less when I do my little wiggle here. So that's good. So we can always just up our softness, and that'll help with really slowing this down and reducing the amount of force we're putting on this object. Now you can always set this to whatever you want. In my case, I have it set to 1.35, and we might want to set it to higher later, but at least with this, it'll help with a lot of our issues. Now, since we have this basically set up, there's a lot of options in here. And I figured it would be good for me just to kind of quickly run through them. So linear limit is the limit on your linear motion. So X, Y, Z motion. Linear motor says, hey, I want this object to be at X velocity at all times. And it's always going to try to get to that velocity if it can. Linear spring determines how much it springs. So that can help with some of your jiggle issues that we're running into. Angular limit does the same thing, whether or not it can rotate on X, Y, or Z axes. Angular motor is how much it wants to rotate this object. So for instance, if you wanted it where when you picked up the object's going to rotate in the character's hand, then the angular motor can allow for that. An angular spring, of course, allows you to make an object spring, right, and reduce the amount of spring that an object has in an angular fashion. So that's more or less what these are for. Now, once we have this, we basically have our grabbing and dropping system working. Now we just have to make it so we can throw our object. So we'll need to set up some kind of throw button. And in my case, it's going to be the left click button. So we'll go to project settings, input map, and we'll just type throw. We'll click add, and then we'll click here and we'll click on mouse buttons, and we will add in the left mouse button. And that will allow us to throw our object. Now, if we go into our player script and we scroll down, there's a section in here where we're doing our input and we're doing our raycast right here. And since all of our input stuff is here, we just need to add that in. So we'll just come down here and just say if grabbed object does not equal null, then we could throw our object, right? So if input.isAction just pressed throw, then you can now throw your object. So what we'll say is first we have to release our object, right? To throw it, you need to actually say we are no longer grabbing this object. So we'll say grab object, and we'll just pass in our grabbed object. And then we can just apply pulse to it, right? We can just say, hey, apply an impulse. But this will not work, because if you run this function here, grabbed object, then the grabbed object will become null. And then we can't apply impulse to a null object, so it's going to crash on us. So what we have to do is we need to assign that object to a temporary variable. So we'll say rigid body 3D temp is equal to grabbed object. And then we could just type temp dot apply impulse, and we can throw an impulse at it. Now we will need to actually apply an impulse from somewhere, right? We can't just apply an impulse and just say, hey, throw an impulse on this, because Godot doesn't know exactly where we're going to be pushing our object from. So we need to tell it. So what we can do is we can just grab our camera. Now, I don't believe we have a global reference to our camera. At this rate, we probably should get one. So I think I'll set one up. So we'll say private camera 3D camera. And then we'll just come down here and set that up. So we'll just come in here and say camera is equal to, and we'll just grab this bit of code here. I'm going to control exit like that. And then I will pass in my camera like that. And then I will grab this guy and pass in my camera as well. That just helps with making everything a little bit more consistent, a little bit nicer. And then we can just come down here and say apply impulse. And how we're going to do it is we need to get where our player is versus where the object is. And then we need to apply the opposite impulse. So how can we do that? Well, what we can do is we can grab our camera, get its global position, and then minus our temp object dot global position. And we can wrap this in parentheses like this. And we can do what's called dot normalize. Okay? And normalizing an object basically just takes it from whatever your value is and does it from a 0 to 1 scale. So it basically creates a line. It says, this is the direction of a thing. Now, I know that you could just say dot direction 2, and that's another option. It basically is the same code, but I wanted to do it this way because it's different than just dot direction 2. And then we can multiply it by -1. And then we want to multiply it by our throw force. So I'm going to hit multiply by 5. And I'm just going to throw 5 in there because I feel like 5 is a good number. But you guys can put whatever you want. And that should pretty much do it. So if we go back to Godot and we hit play. And we look at this object, we hit E. And then we click. We can now throw our object. And that's pretty much it. So we can hit E and throw. Perfect. Now we just have to add sound. And sound should be fairly easy, hopefully. And what we'll do is we'll come over to our grabbable object. And since grabbable objects can be technically anything. I don't really want to just say, this is the sound that I play when I get thrown. So I think it might be good to structure it kind of like we structure our surface. So we can share sounds, we can share references and things like that. So what I'll do is I'll come in here and I'll create a resource, much like we did earlier. So we'll just right click, new script, and we will call it interactable resource, like that. And we're going to inherit from a resource. There we go. And unfortunately, we don't have any templates or anything fancy like that. So we'll just hit create and then double click on it. And there we go. Now, all we have to do is set up our actual resource object, which should just have two things. The first one is the sound that it plays when it hits an object. So we'll just say public audio stream, hit sound wave. Might as well stick with our naming convention we had. And then we also need our export what sound level. So public int noise level. And that's just what sound level it's going to play when you throw it. Now we may or may not get to our AI update. Kind of depends on how much this actually takes up. But hopefully we'll be able to get this. So now, once we have this, all we have to do is go to our interactable object, which I believe is called Pickupable, which got put in our scenes. So we'll come up here and we'll just say public interactable resource, item resource, and we'll go ahead and export that just like that. And now all we have to do is basically just whenever this object hits something, it can play our sound. We could do a lot here, okay? We could come into Godot and we could actually hook up our node signal body entered, right, to it, and then create a function, right? And just have on grabbable body entered, right? But if we do that, then if we assign this to another object, then it's not going to mesh really well with that. So what we should do instead is we should subscribe to that signal on our ready. So if we just type body entered like so, plus equals, and then we can pass in an actual function. And I'll just say tab pickupable body entered because it's already suggesting that and it'll solve that whole issue for us. So then we can just do our code inside of here. And then no matter what, any object we assign this to, if it's a rigid body object, this code's going to work. And that's kind of the name of the game, is that we want our stuff to be as flexible as humanly possible. Now we also want to play our sound, so we're going to need an audio stream player. So we'll create a variable up here. So private audio stream player 3D, and we'll pass in our audio stream player 3D, and I'll make that a lowercase a. I don't know why Visual Studio suggested a uppercase a, but that's okay. And we'll paste this in is equal to get node audio stream player 3D, audio stream player 3D, and then we'll just change this to capital A and capital A. And there we go. And now we can just come in here and play our sound. So we can just say audio stream player 3D dot stream is equal to item resource dot hit sound wave, and then audio stream player 3D dot play, and that'll play our sound. Simple enough. And now all we have to do is just set this up inside of Godot. So we can come in here, go over here, scroll up, and build our project. And you'll see we have an item resource. And now we can just come in here into our sounds. We can right click, add in a new resource, and add in a resource. And if I type, for whatever reason, and I know somebody said earlier that this worked for them, but if I type item resource, it doesn't come up, and I'm not sure why that is. So I'm just going to type resource, and we'll just call this grabbable object. And we'll just set our script equal to our interactable resource, and that'll set this up for us. And then we can just come in here and grab any sound that we want, and it will play that sound when it gets hit. So in our case, I'm just going to do the jump land sound because that's the closest sound that we have to something, you know, smacking into something else. And if we've done everything correctly, if we hit play, and if I come in here and turn on my sound, I'm going to shut off my music real quick. There we go. And then if I come in here and I pick this guy up and I click, well, it doesn't do anything. So why is that? Well, it's because we're not actually detecting our collisions. If we click on our grabbable object down here, you'll see that it says contact monitoring. And if contact monitoring is off, it will not report collisions. So we have to click that on, and then let's just set this to something like 1 or 2 or 3, and that should work. So if we hit play, let's try that now. So we'll grab this guy and we'll throw him, and we got nothing. Well, that's not a good sign. So what is going on? Well, we have 8 errors, so that's good. Delegate, object reference not set to an instance of an object, so that's not a good sign. So our hit sound wave is not set instance to an object, which is probably because our item resource is null. So let's grab our item resource, let's drag that guy in, and let's hit play. And then let's throw it. And you'll see that it plays our sound. And there you go. Let's go crouch down and grab this guy and throw him. And that's pretty much it. So now our object actually plays sound. Awesome. So now all we have left is to get our enemy to detect that sound. And that's going to require one heck of a refactor. So let me quickly stretch my legs and then I will be right back. All right, so what we'll do is we will come over to our enemy script and let's take a look at it real quick. So if we head over there to our enemy script and we scroll down here and we hit Control M-O and we collapse everything and we scroll down to where our check for player is. If I remember correctly, that's where we're doing a lot of our logic here. So we have all of our logic right here. Now, in our design, we said that we were going to pull all of these guys out and put it into its own function. So let's do that. So first, we'll just grab these guys. We will Control X to cut those. We'll pull up here and we'll create a new function right here and we'll just call it private bool, because that's basically what this code is doing. And we're just going to say is sound loud enough. And we'll just pass in a double noise, and we'll pass in if we're behind a wall. Like that. And then we can basically just paste this guy in here. Now we're going to need to do a lot of changes here. So we have if player is in earshot close. We don't need to worry about that anymore because we're not going to worry about the player because we're basically allowing any object to work. So we don't really need to check for that. We know whether or not an object exists, right? If it's there. So that will be fine. And we need to check if we're behind a wall. So that's where this comes in. So we'll just paste this guy like that. And instead of doing player.player.noise value, let's just basically change this to noise like so. And we'll need to pass in some kind of position, right? Because we have this player.global position. So let's just pass in a vector3 position, and we'll just drop that right here like that. And then we'll basically do the same thing down here. So paste, paste, and then distance to position like that. Now, if our player is not crouched, we don't need to worry about that anymore. It's not a big deal. And instead of us setting our current state to chasing, because if we throw an object and it's close enough to the enemy, they probably wouldn't immediately go into chasing. They'd probably still go into hunting. So we'll stick with that. And you'll see that these guys are sharing a lot of the same code. So let's just get rid of these like this. And then let's just say return true, and then return false. And that'll basically allow us to say, okay, if this is true or this is true, then return true. Now, you could really be fancy if you wanted to and actually combine these. You could wrap this inside of a gigantic wrap like this, and then you could just grab all of this, Control X, and you could paste this, and then you could say this or this. And we'll need to wrap this guy as well, like that. And that technically would work as well. So you could actually do this, and this should work. Now I'm going to grab this or, I'm going to put it like this, and I'll put this like, and then we just need to set up our code. So we got to walk backwards. So what do we need to do? Well, we need to determine if an object is in our view, right? We need to determine if an object is in our view, what if there are multiple objects in our view? So that means we need to actually have a list of objects, right? So we need to pull that. So let's actually do that real quick. We'll just come up here and say private list of node 3D. And we'll just have sound objects, and we'll make that equal to a new list of node 3D. And then we need to actually add objects to our list. Is we can come down here and we say when an object enters into our close hearing or far hearing, we can basically just add it. So we can come down to our close hearing. We say if object is player, or if it's type interactable, so obj is interactable, like that, then we can just say if not sound objects dot contains our object, then we can just add it. Because we don't want to add it if it already exists, because then we're going to have duplicates in our array, and we don't want that, or in our list, I guess, in this case. And then the same thing down here. We want to basically do the exact same thing. So, or obj is interactable, right? And we can pass these guys in here. We can get rid of this player as an earshot. We don't need to worry about that anymore. And then we could just say if sound objects contains our obj, and if it does, then sound objects dot remove our obj. And we want to do a bit of error checking here, because if not, and the object somehow is here but never got added to our array, it could break everything. So we want to make sure that we avoid that. And then same thing for far hearing and far hearing exit. So we'll basically just grab this bit of code here. We'll paste it in. We'll grab this bit of code here and we'll paste it in just like that. We just need to basically check if we're behind a wall. We're going to have to check if that object actually exists behind a wall. So we can come up here and basically just grab this bit of code here. And I think we could pull all the way down to probably right here. We'll just copy this and we'll come up here and we'll just say private void bool check if object is behind wall, and we'll pass in a node 3D obj like so. And then we'll just paste this guy in here. We'll hit enter and we'll close these guys off like that. And that will basically work for us. Now, all we have to do is just say player behind wall is true. If we raycast, then player behind wall is equal to false. And obviously we don't want to say player behind wall. And then of course we can return it right here. So player behind wall. And we don't really want our player behind wall to be called player behind wall. It doesn't make sense. So we should just change this to obj behind wall like that. And then we can say if node is player or node is interactable. And that will solve that problem right there. And all we have to do after this, after we have our check for items and we have We have our sound and we have our object behind wall. Now we just have to do our logic to check our items for our sound, right? So we can just come up here, hit enter, enter, and just say private void check items for sound. And what we'll do is we'll basically just loop through our items. So for each var item in sound objects, then we can just basically check for it. So if item is player, then we can basically just cast our item as a player. So player is equal to player.item, and then we can check if sound is sound loud enough. And then I could just pass in the player dot noise value, comma, check if object is behind wall, and we'll just pass in our player. And if it is, then we know that our current state is equal to states dot hunting, and we know our navigation agent dot target location is equal to our player dot global position. And then we should be good to go. Now we do have an error right here. There is no argument corresponds to formal isolation vector 3. So we'll need to pass in our player vector 3. So player.position like that. And that will actually we should probably pass in our global position. So we'll pass that in. Now what this does is it basically loops through and checks if our item is our player. If it is, then it says, hey, is it loud enough? Is he behind the wall? Where is he located? And then it sets its state to hunting if it hears them. Now, this works, but it only works for our player, right? We need to be able to check for our actual items as well. So we could just say if item is interactable, then we basically just do the exact same code, just slightly different. So we'll just say interactable is equal to interactable item. And then if all of this, we could basically just copy it, paste it, and then basically just change this to interactable dot. And we don't really have a noise value, but we'll add that in a second. And then we'll need to check if object is behind wall. So we'll type in item and we'll pass in our item as well here. So interactable is only going to be used specifically for our noise value. So we'll say get, I believe we had sound for our value there. And there we go. And that's pretty much it. And our interaction system should work. Now, we do need to actually set up our ability to run this bit of code. So we can just basically copy this and come up here to our process. For right now, we'll just drop it in right at the beginning, just so I can see how it works and if it works well. And then we can figure out where we want to slot it into our state machine later. But I think that that will work. And you can see we have our check items for sound, interactable. I think that will work. Now we just have to make sure everything's hooked up. So let's head back to Godot real quick. And let's take a look at our grabbable object. We have an item resource. It has a noise level. Let's set that to something like 10, I want to say. I think that will work, and I think that'll be good. So all we have to do now is go into our test level here, instance one of our grabbable objects. So let me come into our scenes, and let me grab my grabbable object. Let's just drag it into the world, and let's put it something like right here. And let's grab our player, drag him down just a tiny bit. And let's hit play, and that's going to play the wrong scene because I forgot. All right, let's hit play on this guy. So we'll pick this up. And we have lots of errors right here. So let's take a look at them. Interop error. Method not implemented. Non-implemented method. Pickup, double pickup gets sound. So this is on enemy 240, it looks like. So let's take a look at our enemy code and let's see what we come up with. So if we come over here and we go into here and we go into our enemy at line 240, 234, 240. Oh, so we have our object here. We're going to need to say obj.globalPosition, and that should work. We might need to make some small adjustments with how we're handling this for our player, but we'll burn that bridge when we get there. So let's head back to Godot here, and let's see if that works. And I forgot. So let me go to project settings, because I'm going to keep forgetting. I'm going to go to general, go to run, and I'm going to set this to my test level, and we'll hit play. And we have lots of errors. So you can see it's spun up quite a few. Get sound is not implemented on our Pickupable, so that's my fault. So you can see here, we don't actually have a noise value. So when the object hits something, so you can see when this body enters, it's just playing. It's not actually setting a noise value. So we're going to need to actually set that up. I completely forgot about that. So what we'll do is we will come up here. We're going to create a noise value. So we will say private double noise value, and then we'll come down here to get sound and just say return noise value like that. And then we'll come up here and we'll just basically say noise value is equal to our resource. So item resource dot noise level. And then we need a way to set our noise value back. And there's a lot of ways that we could do this. And I'm sure someone's going to throw me in the comments and say, hey, do it this way. But what I'll do is I'll just do it in my process, and I'll just say, hey, if my noise value is greater than 0, then we'll set up a small counter. We'll just say private float current count is equal to 2f for float. And then we'll set another one for reset count. And then we'll basically just come in here and set current count minus equals float delta. And then we'll say if our current count is less than or equal to 0, then we will go ahead and set our noise value back to 0. So noise value is equal to 0, and then current count is equal to reset count. Now we could do this maybe with doing something like a yield next frame or next physics frame. Maybe that would be a better method than this, because the way this is going to work is that it's going to basically wait for a second. Okay. And we could set this to something like 0.2 of a second. And if we just wait 0.2 of a second, that's enough time for it to hear the sound and react to that sound. Whereas if we set it to something like, 0.1, there might be a possibility that it might get done before we're able to react to that. So I think that should work. So let's try that and let's see how that goes. So we'll jump into our test level. We'll hit refresh. The enemy's coming at me. You can see he's searching for me. So he looks away. I'm going to pick up my object. And you'll see he's come over here and he's checking for it. Nothing. So if I throw this guy. Oh, he didn't quite notice that. Oh, he saw me. Let's try that again. It looks like it's working, but I want to do a bit more testing. Well, he was already in a search pattern. So he's headed to me. You see that? So he heard the sound, but he's headed towards me, which means that there's a problem. So let's take a look at some of our code and let's see what's going on. So it looks like it's part of our enemy code. So let's head over there and let's see what's going on. So if we scroll down here to our check item for sound, you'll see that we have our player here. Instead, we should be doing item.globalPosition. That's my fault. I don't know how I missed that. So now if we head back here and we hit play, you'll see he's going to come over here because he heard me jump and land. So he'll come over here. And then if I pick up this object, Maybe not. He's definitely pretty blind, but there we go. See, he just went to the object, which was what we were looking for. So if I throw this, he looks at the object and then it continues to ignore it after it's been reset. So awesome. That looks like that's going to work. Great. So I think at this point, we're pretty good. We have it so that we have an interaction system that is extremely flexible and very easy to use. We have a object pickup and throwing system, which seems to be working pretty well. We have a way to distract our enemy and to create sounds and actually, make it so the enemy can hear us. And it gives us a lot more emergent gameplay. So that's awesome. So I think I'm going to leave it here because I think that's pretty much everything that we need to cover in this small video. So next, what we'll do is we will build out our next level and we'll start looking at building a level streaming system. So when we walk up, how do we load levels? How do we handle things like that? So hopefully that'll be our next video. It kind of depends on time and things like that, but hopefully that'll be our next video. So look forward to that. But that is all I have for you guys today. So thank you so much again for watching. I'll see you all next time. Thanks.